Welcome to qnawire.
Person that's standing on the floor and they bend their knees to jump up, and they do reach a certain height of 15 centimeters, and that person weighs about 60 kilograms. Um, so it has a series of questions asking you to figure out what's going on with the system. So the first thing they ask you is, does the floor impart any impulse on this person here? So you know that if they're standing on this floor here, the person exerts a force downwards that is mg, but then the floor also exerts a force upwards, and that's the normal force. And as this person is jumping here, these this force here is acting on this person for a certain amount of time. So the reaction to the changes in motion that he's trying to do here will take a certain amount of time, which means that there is an impulse that is equal to a force times a certain time here. So as they're jumping, they are exerting a larger force on the ground, which in this case is going to cause a larger reaction on them, which would mean that you have a force term here that's acting at a certain amount of time. So you do have an impulse on the system. So that's the answer to A. So the answer would be yes. And then the next part is saying, does the floor do work on the person? So we know that work is force times the distance. Um, so if the floor is going to do work on the system, then the force provided by the floor has to move a certain distance here. And we know that the force is not going to move any distance here. So this is from just the definition of work. We can see that that's equal to zero because that term is zero. So essentially you can determine that no, the force, this floor is not doing any work on the system because there's no movement relative to the direction of that force. And then part C is asking you to calculate the momentum that the person leaves the floor with. So you know that they get to a certain maximum height here of 15 centimeters. So at least you know that when they get to this point, they have essentially potential energy. And that potential energy has to have come from somewhere. So they have to have created this potential energy from somewhere. So that place, that somewhere, essentially is the kinetic energy that they had at the beginning of their motion. So this is just saying that the kinetic energy is converted to potential. So now we have common masses, and we can see that the velocity is actually going to be the square root of 2gh, which in this case um, gives you the velocity. But you want the momentum for this question. So you want to now just multiply this by the mass. So it's going to be so P is going to be essentially the mass times the square root of 2gh. And once you compute this with the values that are given, you see that your momentum is about 103 kilograms meter per second. And then the next part is saying, does it make sense to say that this momentum came from the floor? And the answer indeed is that it does make sense that this momentum came from the floor because um, essentially you have the reason that this person goes up is because of this reaction coming from the floor. So if they have to move up, then they need a certain force to cause that motion to happen. And anytime you have an impulse, then you have a change in momentum. And the impulse in this case, we realize that there is an impulse from the floor. So it should follow that there should be a change in momentum that is caused by the floor as well. So the answer here would be yes. And then, so part E says, what's the kinetic energy that the person leaves the floor with? So if you already have the momentum, the kinetic energy would then be straightforward to compute, because you know that P squared over 2m is actually related to the kinetic energy. That's actual fact, that is the kinetic energy. So that means that the kinetic energy here, once you square this and divide by 2 times the mass, you see that the kinetic energy that you get is somewhere around 88 joules in this case. And then part F says, does it make sense to say that the energy came from the floor? And in that case, the energy does not come from the floor. The energy that gives you this motion here comes from the fact that this body is deforming. So it's changing shape. And that change in shape essentially amounts to some kind of rearrangement of particles. So a change in internal energy gave you essentially a conversion into kinetic energy, which then changed to potential energy. But the floor itself does not actually give you any energy. So there's no energy transfer from the floor in that case.